students, I am Raghu. I have 12 years experience in NEET coaching. I worked in various corporate institutions. Okay, okay. In NEET exam, chemistry is very good scoring subject. If you do properly practice and reading, chemistry will give good scoring in NEET. Average more than 140 marks easily come in chemistry subject. Okay, easy subject only, but you should properly practice and daily topics. Daily practice means easily you can get good score in chemistry. Okay, chemistry having three parts: physical, organic and inorganic. Maximum three parts equally come in NEET exam. Okay, we have start from 11th portion, first chapter, structure of atom. It is very basic chapter to overall chemistry. That's why again one time we can revise basics in structure of atom. I think already you knowing these basics in your previous education plus 1 and plus 2, but one time again we will recall the subject. Okay, so first chapter, structure of atom. Structure of atom. This is basic subject. Basic subject. In NEET also from this chapter, two questions will come. First of all, what is atom? What is atom? First question. Next question. Is atom divisible? Is atom divisible? Okay, atom is the one standard unit. Previous days, that means before 18th century, John Dalton and other philosophers and scientists explained. John Dalton and other philosophers assumed atom cannot divisible. Okay, they can assume atom only ultimate unit. But later many scientists research on atom. Finally they can do experiments on atom. They explain atom can divisible. Atom can divisible. Okay, atom can divisible as a particles. That is like electrons, protons, then neutrons, positrons and neutrinos. So finally later scientists can decide atom can divisible as the particles, that is like electrons, protons, neutrons, positrons and neutrinos. Okay, this is the introduction of atom. Already knows, just recall. Then here we have important topic, cathode rays. That means J.J. Thomson experiment can arrange one electrode metal rod, that is anode. It has positive charge, anode. Okay. Here we can arrange high voltage current. Here high voltage current. Okay, here vacuum pipe, this is vacuum pipe. Here you can apply low pressure, apply low pressure. Okay, when the high voltage current can apply to discharge tube, some particles or some rays produced at the cathode electrode. After producing, these particles can move towards anode. So J.J. Johnson, what he observed, when the electric current applied to the discharge tube, some rays can produce at the cathode and these rays can move towards anode. Okay, this is the first point. He observed some rays produce at cathode and moves towards anode. So you can observe first one. Second one, this is first one. Next to second one, these particles in presence of electric and magnetic field without deflection can move in straight line. This is the second point he can observe. In presence of in absence of electric and magnetic field, these rays without deflection can move in straight line. Okay, that is the second point he can observe. Next, third point, if in presence of electric field, these particles deflection towards anode direction, like that. In presence of electric field, these particles can deflection towards anode. This is the second part. Next, what he observed, in presence of magnetic field, these particles can move, deflection towards that if absence of electric and magnetic field, these particles without deflection can move in straight line. Next point, if in presence of electric field, these particles can move in anode direction. Third point, if in presence of magnetic field, these particles can deflection towards south pole. Electric field means deflection towards anode. Magnetic field present means deflection towards south pole. So absence of electric and magnetic field means no deflection, just can move in straight line. Okay, this is the you can observe. Okay, next one, nature. Next, fifth point you observe, these particles or rays consist of negative charge. Negative charge is called electrons. Okay, these particles, Thomson observed, consist of negative charge. That's why these are called electrons or cathode rays, or negative rays also we called negative rays, because these are consist of negative charge. How we can decide these rays having negative charge? Simple one. What is that? These rays move towards anode now. These rays move towards anode. Anode what charge having? Positive charge. Generally, positive charge electrode direction, which particles can move? Negative particles. That's why anode has positive charge. These particles move towards positive charge electrode now. That's why we can decide these are negative particles. Generally, negative particles, positive particles attraction. Negative particles only move towards positive electrode. Otherwise, positive particles only move towards negative electrode. That is generally already you know it. So this is the Thomson observations. Next, another important point here, Thomson experiment, a cathode rays experiment. These cathode rays cannot depends on nature of the gas. Important point for this one. Nature of the gas cannot depend on nature of the gas and nature of the material. That means what material we have to use in cathode rays, cathode tube. These rays cannot depend on material as well as cannot depend on nature of the gas and nature of material. Okay, this is the another important point in Thomson experiment. Next one. We should apply low pressure. And high voltage current. This is the nature of the cathode tube. This is the J.J. Thomson experiment or cathode discharge tube experiment. It is did by J.J. Thomson. Next one. J.J. Thomson only gives charge to mass ratio he given charge to mass ratio of electron, experimental value given, that is 1.758820 into 10 power 11 coulombs per kilogram. Here coulombs indicates charge, kilograms indicates mass. Okay, this is the charge to mass ratio of electron. It is given by J.J. Thomson. Next one, charge of the electron. Only charge of the electron. Okay. Another scientist, R.A. Millikan are given charge of electron by oil drops method. Okay, we don't need that experiment. Just oil drops method. By oil drops method, he can give an experimental value for the charge of the electron. What is the value? He given experimental value, charge of electron equal to 1.602 into 10 power minus 19 coulombs. 10 power minus 19 coulombs. Okay, given charge of the electron. Okay. So finally, J.J. Thomson given charge to mass ratio of electron. R.A. Millikan gives charge of the electron. Finally, we want to find out mass of the electron. Mass of the electron. Okay, mass of the electron equal to charge of the electron by charge to mass ratio of the electron. Because why should we can find out like that means already J.J. Thomson given charge to mass ratio, R.A. Millikan given charge of the electron. Automatically we can easily find out mass of the electron. That's why mass of the electron equal to what is charge of the electron? 1.602 into 10 power minus 19 coulombs. What is charge to mass ratio? 1.758820 into 10 power 11 coulombs per kilograms. The coulombs cancel. Finally, mass of the electron equal to 9.1 into 10 power minus 31 kilograms. This is the mass of the electron. Okay. So first charge to mass ratio J.J. Thomson given. Then charge of the electron R.A. Millikan given. From that we have to find out mass of the electron equal to charge by charge to mass ratio. Okay, we have easily find out. Next one, another particles, protons. Already you know protons are called anode rays or canal rays. Okay, so protons find out by or discovered by Goldstein is a scientist. He can discover the protons. What he explains? Protons having positive charge. In protons can move towards cathode electrodes. Then what is the charge of protons? Charge of protons. Charge of protons. Positive charge same. 1.602 into 10 power minus 19 coulombs only. Charge of protons also same, but it has a positive charge. Next, briefly about neutrons. 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 Neutrons discovered by Chadwick. Neutrons discovered by Chadwick. These neutrons not having any charge, that is neutral charge. Neutrons having neutral charge. Discovered by Chadwick. These neutrons not having any charge, just it has neutral charge. That's why we call neutrons. Right. Once we write type of particles, then charge, relative charge, next mass, relative mass, relative mass. Okay, we have discussed each particle. First, electron. What is the charge of electron? 1.602 into 10 power minus 19 coulombs. Okay, relative charge of electron -1. Okay, next, what is the mass of electron in kilograms? Mass in kilograms 9.1 into 10 power minus 31 kilograms. Relative mass 0. Relative mass approximately 0 because electron mass is very less. Next, type of particles. Proton. What is the charge of proton? 1.602 into 10 power minus 19 coulombs. Same charge both. What is the relative charge? +1. What is the relative charge? +1. Next, what is the mass of proton? 1.673 into 10 power 27 kilograms. Relative mass +1 in microns. +1. Next one, neutrons. What is charge? No charge. What is relative charge? No charge because neutron has the neutral particle. What is the mass of neutron? 1.675 into 10 power 27 kilograms. Relative mass +1. This is about the particles. Electron, proton and neutrons. Just comparison among the particles. Okay, next one. Just one simple question. One simple question. Simple one. If mass increases, if mass increases, okay, charge to mass ratio of charge to mass ratio of charge to mass ratio of electron increases. Electron increases. Yes. Answer increases. Increases. Because electron charge to mass. So electron mass is very less. Denominator value very less. So electron mass value very less. Very less. That's why if mass increases also, this is denominator value already electron value very less. Automatically charge to mass ratio of electron increases. Then charge to mass ratio of increases. Then charge to mass ratio of proton. Charge to mass ratio of proton. Okay, because otherwise just comparable. That means which has proton or electron, which charge to mass ratio increases while mass increases. Now you can understand easily. So listen. Electron charge to mass ratio. Proton to mass ratio depends on nature of the gas. Depends on nature of the gas. So this is differences. Differences important. Electron charge to mass ratio does not depends on nature of the gas. Proton charge to mass ratio depends on nature of the gas. Okay. Next, these 2 points are important. While mass increases, electron charge to mass ratio more than proton charge to mass ratio. What is the reason? Proton mass more than electron mass. That's the denominator value more means total value less. So this is the concept about cathode rays tube, charge to mass ratio, and comparable of electron, proton, neutron charge, relative charge, mass, and relative mass. Next, nature of the both charge to mass ratios. Okay, this is the today topic.